Okay, please welcome Alex to the stage, and Alex will talk about a gentle introduction to property-based testing.
Thank you, Tobias. Um, Thank you. Yes, so this is a presentation I've done over the last couple of months. I did it at Hackathon as well in the Netherlands earlier in July, and I thought it would be interesting to repeat it here. How many people in the audience are familiar with property-based testing already? Hannes, Peter is, but he's not raising his hand. Um, so I'm using Erlang as an example language, but you should be able to completely ignore the Erlang part. It has actually nothing to do with what I'm trying to teach here. Um, the talk is also going to go over a bit what unit testing is and how we use it and how property-based testing differs from unit test. We're then going to try to use a library called Proper, an Erlang library, which is developed by various open source contributors and is available freely on GitHub. Afterwards, we can take some questions if there is anyone. I think the talk is going to take 20 minutes or so. So there are some concepts we need to be familiar with before we begin. We have these things called a generator, and we have something called shrinking strategies. And those two things are tied together. So a generator is basically a way of generating random values of a given type. It can be a string, it can be a list, it can be an integer. And usually these generators should be able to compose. So you should be able to say, I want a generator of a list of integers, or I want a list of integers or strings, or a list of integers, and so on. Because we use randomness in the test, we want to have some kind of way to reduce the size of these generated values. And from that, we have the concept of a shrinking strategy. So when the system encounters an error, it will try to shrink the given generators until there is a base case, a minimal test case where it will still fail. And for example, for list, it will be that we shrink towards the empty list. For integers, we will probably shrink towards 0. For strings, we shrink towards the empty list, and so on. This is an important part of sort of how it works and how it's actually useful to read these things afterwards. If we have entirely randomly generated data, we will have very, very big error cases when we actually find something. So the canonical example we're going to look at today is a very simple API. It's a base 64 encoder and a decoder. We have a function. We're not really caring about how it's defined. We're purely looking at the API. We have an encode function which takes a binary and returns a binary. This will always be a successful operation. There's no way it can fail. We have a decode function which takes one binary and outputs another binary. This might fail. There might be reasons where we get invalid data that are not actually base 64 characters, and thus we will throw an exception. This is not encoded in the type signature, as you can see. So we also have a function called isValid, which takes some encoded data and returns a Boolean true or false, whether the data is actually valid or not. This is useful usually in software when we want to return an error message and not actually take the decode before we start. We can also use it in the decode function to actually test before we start trying to decode. So usually if we had written this encoder and decoder, our first thing we would do would be to start writing some unit tests. We know that the encode function, so this weird syntax with the brackets here is an Erlang binary. It's basically a string which just have a very small memory representation like a C string. What we will do here is that we will check that the function returns a given value that we know we're familiar with. We can use another implementation, or we can try it out and read various RFCs and so on to figure out what the values should be. So here we test that if we encode the empty string, it encodes to the empty string. If we encode ABC, it encodes to YWJJ. This is sort of the first thing we test. So this test is very familiar with, is very much similar to the decoding test, which is just doing the opposite. So we know that decoding the empty string yields the empty string, decoding y, w, j, j yields abc. So we are starting to see some kind of symmetry here between these two functions. There is something to it that these two tests look very, very similar to each other. And this is what we want to then look at. Instead, what we do here is that we want to define a property which tests basically the same thing but with random data. So what we say here is that we have a data field here, which is a binary. The binary here is a generator. So this will generate random data, and the data variable will then contain this random data. We then say that encoded data is equal to encode data, and data should be equal to decode encoded data. So this, like the last line here, is some kind of assertion, and this function will return true and false. And it should return true for all inputs. That's basically what we say here with the for all macro. This is a good property test. Like, this is a start for a typical encode-decode example, but it has some problems. It shouldn't stand alone in this way. If we replace the encoder and the decoder with the identity function, we will see that this property will still hold for all inputs. And thus, it says absolutely nothing about base 64 per se, but more about the encoder and the decode property that we're testing. So this should, of course, go together with some unit test to sort of lock down your API until you feel comfortable with it being correct. So, a property we can test for in base 64 is when we can calculate the output length of things we encode. And that is a property we can also include. We know that base 64 output is equal sign padded at the end. So we could extend our property to log it further down by saying that the byte size of the encoded data should be this formula based on the data input that we gave to the function. And now we have two property tests that starts saying something about base 64 rather than just saying something about the encode and decode property of the code. This is not fully enough. We additionally want to test our isValid function. So this is sort of a definition of our validator. So we say we have a base 64 alphabet here, which is 0 to 9, A to C, and capital A to C, and plus and slash. We then include some Erlang code to actually validate it. It's a pretty simple thing. It just checks that all characters that are in our input is a member of this larger set of, which is our alphabet. This will further lock down our API and our tests us and give us some better results, but it has some problems. Now this property test is simpler. It's very similar to the first one we had. The only difference is that we just check that our encode function should always yield valid data. It doesn't make sense to have an encoder and a decoder where we generate data we won't be able to accept ourselves. So this property test is much simpler because our function is basically a Boolean function that just returns true, false, so we can use that as our actually test vector. Or as a test, not test vector. This have a problem though with what we did. So the way when we actually run the quick check model here, so proper is the name of the system we use to check it. When we call quick check on the B64 module on the encoding alphabet property test, we will see that it failed. It failed with the input 4. So there is some binary here just containing the 4 byte, which doesn't hold this property. We can now see the shrinking in action. It used shrinking strategy one time. That ended up being able to show us an error case, which is just the 0 byte. So a 1 byte string containing 0. This is of course because we had forgot the equal sign in the base 64 system. So because of that padding to the string, this was an error case that we need to handle. This is not fully correct because of course the equal sign should only be at the end when we padded this. We could extend the property test just for that. So now when we run it, we will actually have, it will generate 100 different tests, feed it through, and we can see that things actually work very well. And it at least holds the properties that we have here. The way it works is usually when you're, can you guys see this? Yes. Proper works where you can run it both on entire modules, where in this case we just say, we have the B64 module run all the tests. We can pass it how many tests it should generate. So here it generates 1,000 tests and runs through. And you can also have it run where you just say run for 12 hours overnight and see if you find anything. So the things that I've left out for this presentation that I think should be added is, there was a lightning talk the other day about concurrency testing in C. Proper has some similar tooling that can be applied to Erlang programs, which is very nice. It fiddles with the Erlang scheduler, so at various yield points when you're sending and receiving messages, it will add some randomness to how things are scheduled in and out. At the former company I was with, we used stateful testing quite a lot to test our database client. Another thing you can do that is pretty nice in Erlang is this library called Niffy, where you can basically include C code and then use property-based testing to test your C code, which is, I think it's a very nice way to reason about C code and get some, feel a bit more comfortable with the C code that you're writing, because we have a higher abstraction layer. So for this is focused on Erlang, is usually the language I prefer. There's also a library called Hypothesis for Python, which is pretty nice. I've been playing a bit around with it. It uses, I can't remember the name, but decorators for functions in the classes, and feels very like it goes very well together with the normal unit test frameworks that are available in Python. For Haskell, there is QuickCheck, and Rust also has a QuickCheck library. I think OCaml also has one, but I cannot remember its name. Qtech? Okay, cool. I know Joe has been playing a bit around with it. For Erlang, there's also a proprietary one, but I'm not really going to mention anything about it. It costs a fortune in licenses, and it's not. Yeah, we can't use it in the open source community because of that, because no one can afford the licenses. Though Proper seems a bit more sensible to me. That was pretty much it. It was a very short talk. Does anyone have any questions? No. Then give a big hand to me. Next talk will be the network team talk.